Loop engineering is the hot new buzzword right now in the AI space for how you go ahead and interface with AI agents. Essentially what it is taking you out from being the bottleneck where you have to prompt the AI agent at each step to tell it what to do next, and actually making it where the AI agent can prompt itself and kind of continue to work through a problem until it reaches a certain endpoint with set criteria. So we'll go ahead and jump right into that today, along with some demos that call out exactly how this works and how you can get started right away. As a quick aside, I'm Hunter Sneed, and I build production automation systems for a living. I'm all about debunking the hype around automation and making sure that it's scalable and reliable for businesses that use in production and to depend on every single day. I've been automating for the last 15 years, and for the last 6, doing it for some of the largest financial services companies in the world. I make sure to bring a practical approach to how I go about solving technology problems, coming from a system design and system thinking mindset. So right now, you are the loop. And what I mean by that is essentially you go ahead and you prompt, and then you go ahead and you wait for the response to come back. You decide if you like it or not, you reprompt, and then rinse and repeat. And basically what this looks like is you can go ahead and kind of queue up some messages and give your LLM some work to do, such as a Claude Code or a Codex. But at the end of the day, you are the decision maker. Sometimes that's a good thing. Sometimes you have to go ahead and you do have to babysit and understand what's going on at each step. But other times when you're doing a larger build out and you just want to go ahead and get through a bulk of the work and you do a good job of actually defining your specifications as well as what your end-to-end requirements are, you don't actually need to do that. And that's really the whole construct behind loop engineering. Basically, it's removing yourself as the bottleneck from prompting and having to go ahead and babysit at each step, and having the LLM make intelligent decisions on your behalf based on the specifications that you've laid out. So that way it can go ahead and just keep building and keep executing without your input. Now, there is some downsides to this, and we'll go ahead and get into that. But right now, remember, you are the loop. So forget the theory for a second, and let's go ahead and let's run a live demo of what this actually looks like and what it is in practicality. So I'll go ahead and I'll flip over to VS Code and show you. This is a super short example and probably not the best for something that is typically for long-running jobs, but you'll get the gist of what we're trying to do here. So I've built a repo here that essentially has a skill in it called preloop that allows you to go ahead and get ready to actually loop or to run the goal command. And so with this, it'll go ahead and ask you some questions and make sure that it understands what it is that you're trying to do and that your requirements and your stop conditions are all very explicit. So that way it can go ahead and run effectively. I also have some bad code in this that I'll go ahead and run to show you how it actually iterates through and fixes it based on the pre-loop and kind of conditions that I've set. So let me go ahead and I'll actually run this script right here, this demo.sh, and this is going to outline some of the conditions here. So let me zoom in, and what we've got here is we have this example directory, and in that it has some intentional bugs. And this is a super simplistic way of actually doing a loop. I'm using the /goal command, which we'll go over a little bit more later, but essentially it's calling out that we need to go ahead and fix all of the bugs for the failed tests that are occurring. And so what happens here is it talks about how we're going to hand it to the actual loop. So we'll go ahead and we'll run this command in just a second in either Claude Code or Codex. I'll run it in Claude Code. And then when it's done, we'll see that the tests actually all pass. It's not about how long it takes, but rather the amount of iterations that it would take. This is something that could probably be one-shotted, but if you're doing this across a much bigger library of, say, problematic code or content that needs revisions or anything like that, the goal or the loop command makes all the world of a difference. So again, let me go ahead and I'll open up a new version of Claude. So let's go ahead and do that. And I actually aliased it to Clauded. And when I run this, it goes ahead and it dangerously skips permissions, which for something like this is actually quite nice. And I'll go ahead and I'll set my effort to max. Not that it should matter for this, but you get the gist. So what we'll do is we'll go ahead and we'll copy this. We'll pop over here. And then what it's going to do is it's going to go ahead and it's going to start on a goal. What you can see here is that it only took one turn in 40 seconds. And for the sake of the demo, that's fine. But really where this is more applicable is if you wanted to do a large feature end to end and wanted to validate it. So you wanted to have it build it out, go and validate that the feature actually functioned, use something like a Playwright, a Selenium, an agent browser to go and actually click buttons in your browser and validate the feature, and then go ahead and really kind of wrap it all up and make sure it's ready to actually ship out in a PR. The whole point here is not that goal is about the number of iterations, but rather that it just keeps trying until it succeeds. And so that may be one turn, that may be 20 turns, that may be 100 turns. It really depends on how complex it is that you're going and actually asking it to do. And it will go ahead and continue to iterate until it gets there. Now, there is some danger with this that it'll actually never stop, and we'll get into that in a little bit, but let's flip back to the deck. You saw in that super short demo that it was able to go ahead and solve the problem and ultimately get it from failing tests to a place where it was actually all passing and ready to go. Now, we just saw goal in action, but you may be asking, why now? What's different? And why are we kind of all pivoting to this loop engineering at this time? And it's a great question. And really what it comes down to is the fact that the model stopped being the slow part of the equation. When these models first came out, responses were somewhat slow, especially the kind of coding, more complex logic that was taking place. But that's no longer the case. Now the models are much faster than really any of us can operate at. And so it's no longer a matter of waiting on the model in most cases, but rather us understanding what the model did, making our own interpretations, and then from there actually going and again prompting it to go ahead and do what's next. A lot of us will go ahead and bypass this and say, what should we do next? Or what's still left to do, to go ahead and kind of get the latest and greatest on what there is to still do. But at the same time, if the model already knows what it can do next and what it needs to do next, there's no sense in us having to go ahead and say, yep, keep going, or yep, continue with what still needs to be done. It can go ahead and just do that until it's actually done. Now, the evidence of this was stronger than ever when the creator of Claude Code, as well as the creator of OpenClaw, both made statements within a week. Boris's statement was, I don't prompt Claude anymore. I write loops and the loops do the work. My job is to write loops. If that's not evidence of where the prompt engineering and kind of prompts or loop engineering is headed, I don't know what is. Basically, we're getting to a point where the LLMs are smart enough when the right guardrails are applied that we don't need to go ahead and actually kind of keep prodding it along the way. We can give it one objective that's clear and defined and measurable and let it go and do its thing. The way that I like to think about this is a prompt is a request and a loop is a control system. Essentially, a prompt is just kind of one set of instructions that it goes and executes on, but then doesn't know what to do next. Whereas a loop is a kind of generalized set of instruction that goes ahead and just keeps checking, remembering, acting, and basically stopping at the end when it has achieved what it is that you're trying to actually do. And so really what this is just the next evolution of prompt engineering. Prompt engineering was making sure that you were providing the right context, the right inputs, all of that to go ahead and basically give the LLM enough context to know what to do next. Whereas loop engineering is really more about kind of the design and making sure that it always knows what to do next rather than having it be dependent on you to actually dictate what that is. I wanted to give a little bit more tangible example as well about what this looks like. So I took a problem of my own. I have a bunch of content on my Getting Automated site that needed proper formatting and tagging and whatnot. And so what I did was I actually ran the pre-loop command. And in this, what it did was it actually went through and it asked me a number of questions. And then it went ahead and created this loop brief markdown document that calls out the intent, the scope, the architectural foundations, the plan, the definition of done, the verifier stack, the anti-goals, the safe execution, the budget, the state, and a kickoff. And so really what this was all about was making sure that it's unbelievably clear that the loop has all the criteria that it needs to be successful and what it is that it's trying to do. And so in my case, it wasn't a feature, but rather some content cleanup that was very necessary. And so what I did was I went ahead and ran it. I ran the /goal. And what it did was it actually went ahead and it went and fixed all these different errors that I had before. It didn't fix the warnings because I actually told it to avoid the warnings entirely. So it listened to what I wanted it to do, but it went through and it fixed all these different content types that were missing the formatting that I expected it to have. And it calls out what the files were, what the fix was, what the warnings are and why it didn't do anything with it, and the guardrails that stayed in place. So that way it didn't deviate from what I asked it to do. Again, a little bit more tangible. I'll go ahead and I'll leave that example in the repo if you want to read through this a little bit more, but this gives you a little bit more kind of context as to what loop engineering is capable of. Whereas previously I probably would have had to prompt all of these different content types or keep prompting, go look for more errors with this or go look for more problems with this and keep having to feed it basically the same instructions again and again and again until it was actually done. Whereas this just kept running it until it got to a point where it said, okay, there is no evidence of any more errors that I actually need to fix. I'm done. Now, I've seen some pushback about loop engineering, and a big part of it is around basically following the money and understanding why it is that the labs are all pushing this. The labs are all pushing this because it quite literally lights tokens on fire. This is something where it just keeps trying until it hopefully gets it right. But in that process of trying, there's a lot of token consumption that's happening. And it's a lot of unsupervised token consumption. So for folks that are not self-hosting a model or folks that aren't on a fixed cost plan, this is something where you don't know if your loop that you're running or your /goal that you're running will cost you $5, $50, $500, or $5,000. And so you really need to be careful about this and understanding kind of both the benefits of when it's generally useful and worth the potential cost, as well as when it's something that you should go ahead and kind of just maybe babysit a little bit more, or understand kind of what the inputs and outputs are and the level of effort that would go into having the LLM solve it for you. We have a loop trigger map. And basically what this does is it goes ahead and calls out different ways that a loop can go ahead and be triggered. What we have is heartbeat, goal, hook, and schedule. And that may not mean anything to you, but basically what a loop is it's something that, again, kind of runs repeatedly until something like a stop condition is met. And so goal is pretty straightforward. Goal is basically when you say, hey, keep running until X is done. And once it's done, that goes ahead and sends a stop condition. The verifier runs and says, yep, this is done. The stop condition goes ahead and basically quits things and spins down. Hook is when you go ahead and you trigger a loop based on something changing. So that could be a file changing, that could be a directory changing, that could be anything that basically kicks off a loop based on some sort of condition or some sort of event happening that changed the state of something. And so where you see state down in the control plane, a hook is basically hooking into state, understanding, okay, did an email come in, or did a file change, or did a commit happen? A hook is something that basically triggers based on something actually changing in the environment. Schedule is like a cron job where it goes and it says, hey, every Monday, go ahead and loop through all my emails and classify every single one until you've classified all the emails that are new within the last week or within the last day. And so schedule is pretty cut and dry. It's basically on a schedule that you denote, a loop spins up and actually goes and does something. And then heartbeat is basically where it's actually going and checking how much time has passed. And so that could be something where you're running a job that takes a long time to complete. So it checks every 30 seconds and it says, hey, is it done yet? No. Okay, let me check again. Is it done yet? No, let me go and check again. And so the heartbeat is basically kind of checking for, again, jobs that are like pulling or jobs that take a long time to go ahead and finish. And so it just keeps checking until it's finished or until an error occurs, and then it goes and does something. All of these are ways that a loop can be engaged and basically allow it to iterate until, again, the stop condition is met. These commands exist today and have actually been around for some time, and they're pretty similar between Claude Code and Codex. Claude Code has a /loop that will basically go and do something on interval like we just talked about. So think either heartbeat, think either time, whatever it may be. Routines and some of these they all bleed together a little bit. But loop basically goes ahead and runs something on an interval. Goal is when you actually go and basically run something until a condition is met. And so goal is using a loop under the hood, but it's all tied to that condition. Routines is something that you see a lot in something like cowork, where it goes ahead and it actually will go and run something on a routine basis based on what you want it to do. So again, whether that's checking emails, maybe doing competitor research, so on and so forth, all of that takes place with routines. The Codex offerings are pretty similar. Again, goal works in the same way. Automations is basically the same thing as routines. And cloud is basically a way to run background tasks. I wouldn't worry about that too much. Just know that both of these function in similar ways, and you can go ahead and kind of alternate or oscillate between the two. They both should give you similar outcomes. Now, let's talk about kind of the anatomy of a loop at a high level. So basically, with all of these, you have a trigger. So we already went over what the triggers are, so I won't go into that much further. Then from there, what it's going to do is it's going to go and collect context. So context could be calling out to MCPs and tools and collecting context there. It could be files on your computer. It could be different connectors that are in play. Basically, it's trying to figure out as much as it can about the problem or the thing that it's trying to solve for before it actually goes and does something. Now, action is where it actually goes and performs what it thinks needs to be done to solve said problem. And so that could be something like editing files. That could be going and actually making changes to existing documentation. Whatever it may be, it's going and doing that corrective action to see if it actually accomplished what it's trying to. With that, there's a verifier. The verifier goes and checks and says, hey, I had the context, I performed the actions. Now, did I actually accomplish what I'm trying to? If it does, then what it does is it goes and it actually updates state and says, hey, this is done. When that state update happens, what happens is it sends a stop command that goes ahead and actually allows the loop to stop executing because it's achieved the goal that it set out to do. And so I wouldn't worry about this too much. This is kind of at a high level, but just understand that all of this starts with a trigger and works its way all the way through to the end where it hopefully stops when it accomplishes the goal at hand. I just talked about verifiers, but there's different kind of verifiers and different ways to go about verification. And so this is the difference between hope as a strategy and proof as a strategy. We all know that hope is not a strategy. Proof is a strategy. The whole idea with proof as a strategy is essentially you provide it, whether it be tests, some sort of evidence, some sort of artifact, something that says, hey, when this is done, at that time, we know that we are done. And so the verifier can go and actually check against that library of tests or those kind of exit conditions and say, hey, can I perform all of these? Are the tests passing? If that's the case, then I'm done. And so the verifier is kind of that last step that checks and makes sure that everything that you're doing is actually verified to be complete before it goes and says it's done. Now, this is way bigger than just code. You can point this at a million different things. I think a support queue is a great example where if you have 150 tickets, a lot of times an agent would go one ticket at a time, solve it, and then say it's done. If you said go and resolve all of the tickets in the queue based on our SOPs and pointed it to the SOPs, it's going to go through and look at every single ticket and try and solve as much of it as it can based on the SOPs that are available. So it's going to go ticket by ticket and not stop until it goes ahead and addresses every single one. That's not to say that it's going to have the guidance or the documentation to be able to solve all of them, but it's going to continue to go and loop and do turns until it actually gets there. Now, the same thing could apply to areas of finance, recruiting, status reports, inbox triage. There's really no limit around this. But really what this means is it's less actually hands-on time and less people that are having to do something and more about actually token consumption. And so what this actually means kind of in a practical business term is you need less engineers or less people more generally doing something and more tokens. And so what would have taken 4 engineers and less tokens per engineer is now 2 engineers and a lot more tokens per engineer. But whether or not that's beneficial to the cost and kind of the bottom line is to be determined. But the idea is basically less people, more tokens is kind of what this is trying to drive. Now, it's really important to know when to use the loop and when to not use a loop. I use a loop when I'm going and I know something that needs to be built out. I know exactly what it looks like, but I don't necessarily know kind of what order it should be built in. But I know when it's going to be done and I know kind of the components that go into it and kind of what my acceptance criteria is. I wouldn't use a loop when it's something that's super cut and dry and there's not a good way for me to verify it. So for instance, if I'm writing content or building a PowerPoint, I can go ahead and tell it to build a PowerPoint, but a lot of times it's not actually it's looking for more of my feedback and criteria and it's a more interactive experience. Whereas if I want to go build an app and I know exactly what the app should do and how it should function and what needs to happen, and I know the architecture, it's a great use case for a loop. What I really like about loops as a whole is that it builds on top of a foundation that we're all used to. It builds on top of plan documents, requirement documents, PRDs, PRFAQs, so on and so forth. And so the whole idea with this is basically that you go ahead and you still go ahead and create the plan document, the backlog, the acceptance criteria, the testing definitions, everything like that. You still have to do the pre-work, but what you can do is you can go and pass that to the loop and it will go and actually execute on all of that. You don't have to babysit it and say, keep building or continue to work through the backlog or whatever it may be. It just keeps going until it's done. And so the plan and specs are still super relevant, but it's one of those things where you don't need to actually go ahead and kind of continue to push it along the way. It just keeps going until it's actually done. And then once it's done, it verifies that it's done and it provides you that evidence at the very end that says, hey, we're complete here. Creating a loop is actually way easier than you think. Really, there are 8 things that go into it. And really, it's just the 4 in the blue that I call it as being the most important. It's the task. What should it go ahead and repeat? What does it mean to be done? What's the acceptance criteria associated with it? How do you verify that it's actually done? And then when it's done, how do you actually stop it? And so these 4 are kind of the core things. If you can do all 8, that's even better. And it's actually quite easy to do with that pre-loop command that I went ahead and talked about actually building out. And so this pre-loop skill allows you to go ahead and basically kind of be questioned around what you want to do. And it goes and gathers context about your repo and everything that you're working on. And it goes and creates that loop markdown document for you. So you can take that markdown document, pass it straight into /loop or /goal, and it has everything it needs to be able to go and execute successfully. And that, ladies and gentlemen, is loop engineering minus the hype. While it feels like this big buzzword, it's really not that different than kind of how we've been building and developing with stuff like Claude Code and Codex. The difference is we're just not babysitting it as much. We're still dependent on kind of the strong foundations around the specs, the requirements, so on and so forth. And so I encourage you to give it a shot and tell me what you think. And if there's anything that I didn't cover, any questions that you have, definitely make sure to comment, like, subscribe, give me the feedback. I'm here to go ahead and create more educational content around this. But hopefully this was helpful, and good luck loop engineering.